Okay, as we start chapter 2 here, you can see at the top of the page our more traditional definitions of sine, cosine, and tangent. Sine being opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. We've discussed that cosecant, secant, and cotangent are reciprocals, so we just flipped a fraction over. Again, I'm going to assume that most of us have dealt with our trig functions, and a lot of us have probably used SOHCAHTOA to remember that or remember our trig functions. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. As I mentioned back in chapter 1, we will use these definitions along with the x, y, and r definitions that we learned in chapter 1 back and forth between our different types of work with the trig functions in our class. Also in this section we have something called cofunctions. Cofunctions simply means that if we have the sine of one angle and the cosine of its complement, then those angles are equal. So if, for example, if you were to type the cosine of 40 degrees into your calculator, it would be the same decimal value as the sine of 50 degrees. Or if you were to type in the cosine of 20 degrees, that would be the same thing, same decimal value as a sine of 70 degrees. 40 and 50 are complementary, 20 and 70 are complementary, and so on. So we have pairs here. You can see sine and cosine are cofunctions, secant and cosecant are cofunctions, and tangent and cotangent are cofunctions. So that, along with what you'll see next, are the basic items here in chapter 2. We'll be working with our 6 trig functions, still finding those values and applying those, solving some problems. We'll also be using our cofunctions here, along with these 2 triangles that you see. The first one is a triangle you had back in geometry called a 45-45-90 triangle. The ratio of the sides of a 45-45-90 triangle are the same regardless of the size. So our 2 sides are the same length. In this case, we have labeled them as 1, and our hypotenuse then is the square root of 2. We could verify that with the Pythagorean theorem if we needed to. So then if I take this 45-degree angle and find the sine, sine is opposite over hypotenuse, 1 over square root of 2, which eventually simplifies when you rationalize the denominator to be square root of 2 over 2. Cosine is also 1 over square root of 2, which simplifies to be square root of 2 over 2. Tangent opposite over adjacent, which is 1 over 1, simplifies to be 1. And then our reciprocal functions, cosecant of 45, the reciprocal of this is the square root of 2. Reciprocal of the same thing is also square root of 2 for secant, and cotangent is 1. So this is an angle, 45 degrees, that is very commonly used in trig. It's part of what we'll eventually call our unit circle, but we can use this angle to find the 6 trig functions of other angles that are related or multiples of 45 throughout our unit circle and beyond. Another commonly used triangle here is a 30-60-90 triangle. And a 30-60-90 triangle, much like our 45-45-90 triangle, has a ratio of sides that follow as it goes. Opposite the 30 is the smallest side, in this case 1. Opposite the 60 is the next smallest side, which is square root of 3, which is essentially the same, about 1.73. So we go 1, 1.73, and then our hypotenuse is the longest side, which is 2. Now, just as a side note here, as I said, this is the simplest side, or the version. The ratio stays the same, so if the length of this side were 4, this side would be 4 square root of 3, and this side would be 8. Or if I erase those, and one more example here, if I made this bottom side, say 12, this side 12 square root of 3, and this side 24. Regardless, once we find our trig functions, they all reduce down to the same fractions, and those are listed over here. Sine of 30 degrees, 30 is opposite over hypotenuse, so it's 1/2. Cosine is adjacent over hypotenuse, so square root of 3 over 2. Tangent opposite over adjacent, square root of 3 over 3. And here's our reciprocals, cosecant, secant, and cotangent. And then using the other angle, sine is opposite over hypotenuse, square root of 3 over 2. Cosine adjacent over hypotenuse, 1/2. And tangent is opposite over adjacent, square root of 3 over 1 or square root of 3. Reciprocal functions here. So through these two triangles, we have three angles that you will see a great deal of over the course of the next several weeks. We'll use these angles to find our trig functions, not only for these three, but also for 150 or 210 or 225 degrees, different angles as we move around our coordinate plane or around our what will eventually be our unit circle. So here, talking about our trig functions, we have triangle ABC. So another side note here, typically in math textbooks, you'll see the angles expressed one of two ways, either the uppercase letters like you see here, or they'll be expressed as Greek letters, which are in different textbooks. For right now, we have the uppercase letters for the angles, and the lowercase letters then are opposite those uppercase angles or those uppercase letters. C is also, again, in a typical math textbook, is designated as the right angle. So if I fill in what we know here, we know that A is 3 and C is 10, which means we could say 3 squared plus B squared equals 10 squared for our Pythagorean theorem, or 9 plus B squared equals 100. In this case, B squared equals 91, or B equals the square root of 91. We're on the coordinate plane, so we don't have to worry about the plus or minus here, but B is the square root of 91. And now we're going to find our trig functions. So let's say that sine of, let's find them for angle A. So sine of angle A is the opposite over hypotenuse, or 3 over square root of 10. The cosine of angle A is adjacent over hypotenuse, or square root of 91 over 10. And the tangent of angle A is opposite over adjacent, 3 over square root of 91, which would rationalize to be 3 square root of 91 over 91. Reciprocal functions, cosecant of angle A, reciprocal of 3/10 is 10/3. Secant of angle A, reciprocal of square root of 91 over 10. I'm going to go straight to the simplified version. I hope we're well enough versed on radicals right now. And our cotangent is going to be the square root of 91 over 3. So those are our 6 trig functions for angle A. We won't do all 6, but let's go ahead and do the first 3 for angle B. So we go to angle B. From here, the opposite side is square root of 91. The hypotenuse is 10. So the sine of angle B is the square root of 91 over 10. Cosine of angle B is 3/10. And the tangent of B is opposite over adjacent, or square root of 91 over 3. So that gives you the trig functions that we had back in chapter 1, but just looking at those in terms of opposite, adjacent, hypotenuse rather than x, y, and r. I think I'm going to go ahead and skip number 2 here and get to our next type of problem here. Number 3 says to write in terms of cofunctions. So as we discussed very briefly earlier, sine and cosine are cofunctions, secant and cosecant are cofunctions, and tangent and cotangent are cofunctions. And the characteristic of cofunctions is their angles are complementary. So the cofunction of cosine is sine, and the complement of 52 is 38 degrees. So if you were to type in to your calculator the cosine of 52 and separately the sine of 38, you would get the same decimal value because they are equal. Those ratios are equal to each other. Tangent's cofunction is cotangent, and the complement of 71 is 19. And secant's cofunction is cosecant, and the complement of 24 is 66. Now we obviously do not have a cotangent, secant, or cosecant function on our calculator since they are reciprocals, and we saw this identity earlier. If you were to type those in, this is typed in as 1 over the cosine of 24, and this is typed in as 1 over the sine of 66. One more, this is 1 over the tangent of 19 degrees. Okay, so we can use our calculator to find those reciprocal functions We just have to use those reciprocal identities, cosine, sine, and tangent to do those, and we can compare those decimal values to make sure that we are correct. So number 4 tells us to solve using our cofunctions. So we notice we have an equation. Cosine is set equal to sine. Since those two functions are equal to each other, that means their angles must be complementary. So if we take theta plus 4 degrees plus 3 theta plus 2 degrees, that should be complementary or equal 90. Now it becomes a simple algebra problem. Theta plus 3 theta is 4 theta. 4 plus 2 is 6 equals 90. Subtract 6 from both sides. 4 theta equals 84. Divide both sides by 4, and you'll find that theta equals 21. So there we have solved our equation for theta. You can see the next two, once we've established that relationship in letter A, the next two should be a little bit easier. Tangent and cotangent are cofunctions, which means, again, that their angles are complementary. Or if we add 2 theta minus 18 plus theta plus 18, that will equal 90. Combining like terms, 2 theta plus theta is 3 theta. Negative 18 and positive 18 are going to cancel each other out. That equals 90. We'll divide by 3, and theta equals 30 degrees. One last time, establishing our relationships. Secant and cosecant are cofunctions. So 3 theta plus 10 plus theta plus 8. Let's try 8 here, not 18. Our complementary angles, or they add to be 90. So when we do our algebra work here, 3 theta plus theta is 4 theta. 10 plus 8 is 18, equals 90, not 92. Subtract 18 from both sides. 4 theta equals 72. And if we divide both sides by 4, theta is going to equal 18. And that should give us a pretty good idea of what cofunctions look like. These next two are quick little calculator problems. We can simply type these into our calculator. One side note I would make here, we haven't talked about radian mode yet, but there is a mode function on your calculator. Make sure you're in degree mode here because our angles are in degrees. We're going to simply type in the sine of 21 degrees. And for purposes here, I'm just going to go to 4 decimal places. That value is 0.3584. And the sine of 18 is about 0.3090. So from those two decimals, it's pretty plain to see, but 0.35 is larger than 0.30. So letter A is a true statement. The sine of 21 is larger than the sine of 18. Talked about this very briefly a minute ago. There is not a secant function on our calculator, so we use our reciprocals. This is typed in as 1 over the cosine of 56, and this is typed in as 1 over the cosine of 49. And each of those decimals is, for this one, we get 1.7883, and 1 divided by the cosine of 49 is 1.52. 1.43. Pretty obvious that 1.7 is larger than 1.5, so in this case, secant of 56 is not less than the secant of 49, so this statement is false. So those are a couple of quick calculator-based problems, probably the easiest way for us to do those right now. And to end this section, we have a handful of problems that are going to revolve around those two triangles that we had out here. I'm just going to try and sketch, and I use the term sketch very loosely here since my drawing skills with this Mimeo pattern not that good. But we have a 45, 45, 90 triangle which has those sides, and we have a 30, 60, 90 triangle which is going to look something like this, where we have 1, square root of 3, and 2. So I guess the bottom line here is you're going to need to know the ratio of these sides because we will use these quite a bit. But going back up here, the tangent of 30, coming to 30, tangent is opposite over adjacent. So it's 1 over square root of 3. We should always have that in simplest form, which means our radical can't be in the denominator, so our tangent is square root of 3 over 3. Sine of 30, sine is opposite over hypotenuse, so our sine is 1/2, 1 over 2. And then the secant of 30, secant is going to be r over x, or hypotenuse over adjacent, which is going to give us 2 over square root of 3, or when we rationalize that denominator, it winds up being 2 square root of 3 over 3. Okay, so that's using those, the 30, 60, 90 triangle to come up with those three. Notice the next 2 or 3 are off the 45-degree angle. Cosecant is reciprocal of sine. Sine is opposite over hypotenuse, so cosecant is hypotenuse over opposite. Hypotenuse is 1, opposite is 2, so 1 over square root of 2. Let's try that again. My bad, I can't read apparently. Hypotenuse is square root of 2. Opposite side is 1, and square root of 2 over 1 is just square root of 2. Continuing on here, cosine of 45 degrees, adjacent over hypotenuse. Adjacent to 45 is 1, hypotenuse is 2, so 1 over square root of 2, which eventually rationalized to be square root of 2 over 2. And then we have 2 or 3 more here off of our 60-degree angle. Sine of 60, 60 is here. Sine is opposite over hypotenuse, so square root of 3 over 2. And tangent, opposite over adjacent, square root of 3 over 1, or just square root of 3. And that concludes section number 1.